All right, hello again. This is Jeff Scott, your instructor for 152-143, beginning Java programming for the spring 2016 semester at Blackhawk Technical College. I've been doing a series of recordings where I have both gone over the first 11 chapters of the book, the PowerPoints, and the first 4 chapters of the book when I go over the actual stuff in the book itself, along with some programmatic examples. So far, I have created, I don't know, about 8 programs, and I believe there'll be 2 more. So 1, 2, 3, 4, 5, 6 programs, and I'm going to create 2 more in a bit for Chapter 5. But before we do that, let's talk about the subject of Chapter 5, which is methods. So far, everything that we've done, we put inside of a main method. That's really not a very good idea when you think about it for a lot of different reasons. Main can get very big, very hard, very cumbersome to work with. So rather than just main, we're going to create other methods. Now we're going to do this in a little bit different way in that in this particular chapter, in Chapter 5, we're going to write methods and we're just going to add to what we have in main. Then once we get into Chapter 6, you're going to see a little bit of a paradigm shift, so a little bit of a shift in thinking, because we're going to pull main out of our program and put it in its own class. All right, we'll talk about that in a little bit. But for now, we want an introduction to methods, talk about how to pass arguments to a method. We'll talk some more about local variables because we'll have several methods, how to return a value from a method, how you can solve problems with methods, and as always, common errors to avoid. So, as mentioned, methods are also known as divide and conquer. They're known as stepwise refinement, but they're a way to take a complex program and break it into small manageable pieces. I don't think I gave this analogy when I did the talk on the PowerPoints, but I'm going to give it right now. When I was about 20 years old, I was a full-time student at the University of Wisconsin-Milwaukee. I had a full-time job as a produce worker for Kohl's Food Stores in Milwaukee, and I also wrote part-time for 2 different newspapers. All right, so in other words, I was fairly busy. And after a while, I decided that it might be a good thing. I was living with my brother. We were sharing a duplex, but he got engaged, and it was very uncomfortable because his fiancée was over there all the time. So I decided to get my own place. And luckily for me, one of the customers who came into Kohl's had a house behind his house. It was a very small little house, wasn't much bigger than a garage, really. It had a little kitchen, 2 rooms, one that could be used as either a living room or a bedroom, and I kind of went back and forth between the 2 of them, and a bathroom. Then downstairs it had a shower, okay? And there was really almost nothing else down there. But the reason I'm telling you this is even though it was a small place, a lot of times when I got home from one of my 3 jobs, the house was kind of a mess. And I'd come home and I'd say, I'm really way too tired to clean this. And I'd put it off. But after a while, you can only put it off so long. So what I'd start to do would be to kind of trick myself. And I'd say, you know what? What I'm going to do is I'm not going to clean the whole house. I'm going to separate it out into units. I'm going to clean the kitchen. And then when I got partway through the kitchen, I'd say, you know what? I still feel pretty good. I'm going to clean the bathroom too. All right. Then I'd get done with that, and I'd say, I'm going to clean the bedroom now. And then finally, well, geez, all that's left is the living room, so I might as well clean that up. What was I doing? I was taking a complex problem like, cleaning up my house, and I was breaking it down into smaller, more manageable pieces. So I was decomposing the problem into a set of smaller problems. And that's what you do when you create methods. All right, so far you've had main, and you really haven't had anything else. We've used some predefined methods that come with the Java API, as the author mentions here, like system.out.println, integer.parseInt, and there have been other ones. But now what we're going to do is we're going to write our own additional methods. All right? So the author mentions, that rather than having a main that just gets so big and has all these lines, it'd be better to do it something like this. All right, and break it up. It does, believe it or not, although it may lead to more code, it simplifies the program, because if you know there's an error in part of your program, all right, you know exactly where to go. So in other words, if I had an error in here, it's one of these lines. But if I have an error and I know it's in method 2, well, now I know exactly where to go to look for it. Plus, if I write these methods, I can write methods that can be reused. So if I'm writing myself a calculator program, I might have an add method that I might call several times while the program is running. All right? So the first type of method we talk about here is a void method. A void method is a method that does its task and terminates. In other words, it doesn't return anything. So if we, I don't know what they're exactly trying to show right here, but really that's what a void method is. It's a method that does not return anything. So main is an example. This is a great example. Remember, this is the method header. We've talked about this before. Public was the access specifier. We've talked about that before, which means this main can be called from anywhere. It's static, which means that there is only one of them. There is only one main. It's void, meaning it doesn't return anything. Its name is main, and it can have some arguments in there that are represented by a string array. Well, notice all we have in here is system.out.println hello world. There's no return, there's no anything. All right? So it's, we could have written the same kind of thing like this. Instead of putting that in main, we could have had our own method that we wrote. And if we wrote our own method called display message there, then in main, instead of actually putting this in here, we could have had a call to display message. And the way that we call that is just using the name of the method with 2 parens. All right? So again, all the different stuff that's in here is explained right here on page 272. I get so sick and tired of reading out of a book, and I don't want to do that to you. I don't think you deserve that. So I'm giving you my take on all this stuff. All right? And there's the call to display message. So again, I've gone through and I've read the book, and I know what the book's about. So as we go through this, again, it's not my goal to read to you. All right, so we're in main. We wrote hello from the main method. We call display message. What that means is right there, control of the program shifts from right here to this routine right here. All right, so it comes in here, it does another system.out.println, it sees the curly brace, so it comes back here. So the output should be hello from the main method, hello from the display message method, back in the main method. And you can see that's exactly what the output is. And that's what the author explains in here. Again, if you really want to understand this stuff, and believe me, there is a big market out there for good Java programmers. If you really want to understand this stuff, my suggestion is that you read through the chapter yourselves fairly quickly. All right? Underline stuff you don't understand or whatever. Then go in and take a look at the lectures that I did on the PowerPoints. Then go in and look at these lectures that I'm doing on the book and where I'm doing the programs. Make sure you come to class. Make sure you listen to all the material that's available to you. All right? When people say, well, gee, Jeff, I'd like to, but I don't have the time. Okay, that's fine. All right. Method calls can be used in control structures like loops. We saw something like this earlier. So what are we doing here? Well, remember, even though we don't have curly braces here, although I wish the author would have, this is going to call display message 5 times. So this should say hello from main method, then it should say hello from display message method, 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 then back in main method. So there's, what did I do, 3, no, it said less than 5, so really there should have been, yep, they're all here. There's main, there's 1, 2, 3, 4, 5, and back in main. All right? So what we have here are just a series of calls to different functions. Again, what we're doing here, I want to make sure you understand that, is everything we previously had been doing inside of main, we're now going to break up and put each one of these things in its own function. Now, just for a second, I don't normally do it this way, but I'm going to jump out of here. And when we get to the Chapter 5, what I've done is I've copied over the Chapter 4 payroll 1 into Chapter 5. Think about what we're going to do here. All right, just for a second, think about it. We're going to take first name and we're going to figure out or input the first name in its own routine. Oops. Then we're going to input the last name in its own routine. Then we're going to input the hours in its own routine. Then the the rate in its own routine. Then we'll figure out the gross in its own routine. Then we'll print out all the information in their own routine. So we've got all the code here. We're just going to massage it and move it around so they're all in their own routines. All right? That way, if we had a problem with the last name, then rather than having to sift through 114 lines of code, all right, and really in a real application, some of these applications are hundreds of thousands of lines. So rather than having one routine with 100,000 lines, we're going to have thousands of routines, ideally each with a few lines, so we know right where to go to if we have a problem. Hopefully that'll make more sense if we start doing this. All right, so they do here is the main calls deep. So it should say I'm starting in main, I'm now in deep. Deep calls deeper. So it says I'm now in deeper. So we should have I am starting in main, I am now in deep. I am now in deeper. I am back in deep. Now I am back in main. So I'm starting in main, I am now in deep. I'm now in deeper. I'm back in deep. I'm back in main. All right. By putting comments, Java doc comments in here, you can make your code a little bit easier for you to read, and that's what the author mentioned in there. I'm not going to go into that in any more depth or breadth of coverage. All right. It is possible for you to pass parameters. It is possible for you to pass parameters to methods. All right, those parameters are known as arguments. Now I want to show you something. Again, I'm going to jump back for a second. What we're going to do in here is I'm going to do it the way that's the hard way, but technically it's the right way to do things. If I took all these pieces of data that we had right here, all our variables, first name, last name, the input string, hours, rate, and gross, 6 pieces of data. If I took all of them and I moved them up here, so they were outside of main, so if I move them up here, then they would be global to the program. I wouldn't have to pass them any place. But that's considered poor programming practice because that means that any routine that's in the program could potentially change them. By leaving them in main like I have them, all right, what you're going to see is we're going to end up calling these routines. We're going to pass this stuff that you see in here into an input first name routine, an input last name routine, an input hours routine, an input rate routine, an input gross a calculate gross routine, and then we'll have a print routine where we'll print everything. So we'll have 5 or 6 different methods in addition to main. Main will be a driver. It will call the other routines. Ideally, that's what main is. Main is kind of like a conductor for an orchestra. The conductor, she or he, does not actually play an instrument, but rather they tell the musicians when to come in, be louder, be softer, etc. They drive the orchestra, and in the same way, main is meant to drive the program. All right, so you're going to see this. We've already done a little bit of work with this, but by and large, anything that you've called, you haven't called anything from main other than built-in Java functions. But now, notice here, it's possible we can call display value, and what we pass in is known as an actual parameter, and what it's called in here is known as a formal parameter. They can be the same name, but they don't have to be the same name. All right, so we're going to pass arguments. Make sure that when you call a routine and you pass something to it like this, don't put the type in. Not in the call, but you have to put the call in when you're actually writing the method. Now, if I went through that too fast and you want more on actual and formal parameters, you can see the note here on the bottom of page 281. When you pass parameters, you got to make sure they're the right data type between being passed in the parameter and actually being declared in the routine itself. Okay? All right. You can pass multiple things, so you can have multiple parameters. Scope I'm not going to hit on anymore because we've already talked about that. So notice in this routine, we're calling a routine called showSum. 5 and 10 are the actual parameters. 5 gets copied into num1, 10 gets copied into num2. All right? And then we return basically num1 plus num2. All right, sorry about that. Just my daughter walked in and didn't know I was taping. So when you pass in arguments in Java, if the argument you pass in is a primitive type, please remember always our 8 primitive data types: byte, short, int, long, float, double, char, boolean. Those are always passed in by value, which means a copy is passed in. So if you happen to change the value of the parameter in the method, it's a temporary change. When you go back to the calling method, it reverts back to its original value. They show you an example of that here, but it's actually a little bit confusing, so I'm not going to go over it. On the other hand, if you pass an object to a method, all right, so if you pass a string, later on we'll get into talking about arrays and array lists. If you pass one of those are passed by what are called reference. In other words, the address is passed. So any change you make to an object is a permanent change. All right, that's one of the differences between them. And they show you that pictorially here. I'm not going to go, again, it's not my goal to go over this in a lot of depth and breadth of coverage. My hope is that when we start to go over this stuff and we look at the example and you see the before and after picture on what I'm going to do here, you'll be like, oh, that makes a lot of sense. Okay? And if we do go over it, be it in the lecture here or in the classroom or whatever, please, it's your responsibility if you have questions to ask them. I don't consider when people say that I got a dumb question. No, it's not a dumb question. Chances are really good if you've got a question, somebody else has the same question. All right, you can use parameter tags in JavaDoc to show what you're passing into a routine. But again, you do not have to do that. But when you do, you get the very API-looking comments that you end up creating by doing that. All right, more about local variables. Again, a local variable is declared inside of a method, and it's not accessible outside of the method unless you pass it to another method. So notice in here, main calls Texas and it calls California. Texas has got a birds in here. California has got a birds in here. They're 2 different variables, totally okay because they're both local variables. The lifetime of a variable, this birds begins life here and it ends life when the ending curly is hit. You must, if you have local variables, so if you have variables that you're declaring inside, if you're declaring a variable inside of a method, you must initialize it before you use it. If you don't, so if you say double sum and then you do the system.out, so in other words, if you try to print that out, the sum, before you set it, you'd get an error message. It would be called a null pointer exception. All right. A method may send values back, so you don't have to have a void method that returns nothing. All right. You can have a method that returns anything. It can be one of the simple data types, the primitive data types. You can also return an object back. Whatever you return, if it's not main, you have to put it in there, and you have to make sure then there is a return statement. So in this example, result must be of type int. If you break the rules in the system, as far as the system is concerned, you break the rules, all right, Java will give you an error. So you notice here, public static int sum. So int result. Result equal num1 plus num2 return result. Result is there. It's been defined there as an int. It's being returned, and the type of return value is an int. Not a problem. It all works, and they show you this pictorially on page 296, so you can see exactly what's happening. Not only can you have Java doc comments for parameters, but you can also have them for return. What we'll do by the end of the semester is we'll write ourselves a program that uses a lot of Java doc comments, just so you can see it and you can make your own decision as to whether or not whoops, you would like to use those. Wrong button. You can return any type of variable. Here's an example of returning a Boolean, which means that you must return either true or false. All right, and again, you can return an object as well. That is totally legit, but only one thing. That one thing can be an object, so that's okay. All right, I think that just about is going to finish the calling methods that throw exceptions here. I'm on to page 306. All right. It says how they have a throws IO exception. Remember, when you have those throws clause, that means that it's possible Java could throw an exception. When we get to chapter 11, we'll learn the other way of handling exceptions, which is to write our own exception handlers or have us throw exceptions rather than Java throwing it. So that is it for the chapter. So I'm going to, again, in just a couple of minutes, because I'm basically finished with this right now, I'm going to go over here, and again, what I have done is I have copied program payroll, chapter 4 payroll 1 to chapter 5 payroll 1, and chapter 4 payroll 2 to chapter 5 payroll 2. This will probably be the last time that I'm going to be doing two programs, one for non-file and one for file, but I'm going to rewrite both of these, and I'm going to rewrite them so that they both use multiple methods. And I'll be back to do that shortly.